Hello, this is Mrs. Ward, and I'm going to go over the notes for section 2.5, implicit differentiation. So the first thing we're going to talk about is the difference between when a function is written explicitly and when a function is written implicitly. Explicitly means that you have y on one side by itself, everything else is on the other side. Those are the ones that we have been doing so far. We've had one variable on one side, even when we had like d of t is equal to t squared. This is basically your y is equal to t squared. We have the one variable on one side of the equation all by itself, the other variable on the other side. When you have implicit, you have both variables on one side and you're taking the derivative in terms of more than one just variable. So the first ones are pretty simple and then they get progressively harder. But up until this point, when we had an equation like this, we would have just rewritten it in terms of y and then we would have taken the derivative. Today we're going to learn how to take the derivative in this format here. So up until this point, when we've taken the derivative, you kind of think that you're only taking the derivative of one side, because if I had y is equal to, and let's go with this 3x squared, we write dy dx. So I'm taking the derivative of y in terms of x, and then I write 6x, and I use the power rule for that. So we've been doing this all along. Now what's going to happen is when I take the derivative in terms of x, this x and this y aren't going to meet anymore, or aren't going to match. So I'm going to think of this as my u and kind of use the chain rule. I'm going to find the derivative of 3y squared, and that's how I get, I'm sorry, the derivative of y cubed, and that's how I get 3y squared. And then I'm going to take the derivative of u in terms of x. So in this case, my u would be y, and that's why I write dy dx. Now up here, you could have written the derivative of x in terms of x. Well, anything written over itself is just 1. That's why we normally don't do that. When you do that, when you take the derivative implicitly, you're going to, all the rules are still going to apply. So I'm still going to do like terms. I'm going to do this term and this term. So the derivative of x is just 1. The derivative of 3y, derivative of 3y would just be 3, and then I'm going to write the dy dx, and that's telling me that originally my variable wasn't the same as the other variable, because if I just wrote 1 plus 3, I wouldn't know the difference between the x and the y's. So that's why we do it that way. So let's do one. The simple guidelines for doing this is you're going to differentiate both sides of the equation with respect to x. You're going to collect anything that has a dy dx on one side of the equation. Anything that doesn't have a dy dx will go on the other side of the equation. And then you're going to factor out the dy dx, and then you're going to solve for the dy dx. So let's do one, because I think it makes more sense to actually do one. So here's a simple one. I have x squared minus y squared is equal to 16. You should recognize that as a hyperbola. But I'm going to take the derivative. So the derivative of x squared will be 2x. Again, I'm doing the derivative of x in terms of x, so I just leave it like that. Here's that minus sign. The derivative of y squared will be 2y. But I'm going to write the derivative of y in terms of x, so dy dx. And then the derivative of 16 is 0. Now, this term has a dy dx, so I'm going to leave that negative 2y dy dx on one side. And then I'm going to take this 2x to the other side, so this will be equal to negative 2x. To solve for dy dx, I'm going to divide both sides of the equation by negative 2y. And when I do that, my derivative of y in terms of x is going to be equal to x over y. So now when I take the derivative, I'm usually going to have more than one variable. So if I wanted to find the derivative at a point, I would need to know the x and the y to find the derivative at that point. Okay, let's do the next one. I have x to the third times y to the third minus y and is equal to x. So I'm going to do, when I do this, I have to use the product rule. So first I'm going to leave the x to the third alone. Taking the derivative of something raised to the third power will be 3y squared. Then I'm going to write dy dx. Still doing the product rule, I'm going to have a plus sign. Take the derivative of x to the third, which will be 3x squared. And now I'm leaving that y to the third alone. Now I'm taking the derivative of this minus y, so this will be minus 1, because the derivative of a variable is 1. Dy dx is equal to, and then the derivative of just this x is going to be 1. Anything that has a dy dx, so this term, whoopsie, that's not highlighting, this term and this term will stay on one side, and then this 3x squared will go over to the other side. So when I write that, I'm going to multiply this up. So I'm going to have 3, whoopsie. I'm going to have 3x cubed y squared minus 1. And these are all times dy dx. Then taking this to the other side, I'm going to write 1 minus 3x squared y to the third. Solving for dy dx, I'm going to divide both sides by this 3x to the third y squared minus 1. So dy dx is going to equal 1 minus 3x squared y to the third. And I cannot simplify anything because they're not like terms. So I'm just going to go ahead and leave it like that. So my derivative of y in terms of x is equal to all that. So this one is, we're going to show that the derivative implicitly and explicitly, you do get the same thing, but they don't look the same. They still give you the same value. They still are the same, but you have to kind of work them to make them look the same. So let's start off with this equation. 9x squared plus 16y squared is equal to 144. I'm hoping that you recognize that it's a conic, and I'm hoping that you recognize that it's an ellipse. I'm hoping. So it says find two explicit functions by solving the equation for y in terms of x. So I'm solving for y in terms of x. So when I do that, I'm going to have 16y squared is equal to negative 9x squared plus 144. To solve for y, I'm going to divide everything by 16. So I'm going to have y squared is equal to negative 9x squared plus 144 over 16. And then to find y, I'm going, oh, it's going crazy on me. I'm going to have y is equal to plus or minus the square root. So I'm taking the square root of this side, square root of this side, and this will be the square root of negative 9x squared plus 144. And then the square root of 16 is 4. So I'm just going to write over 4. So that's part A, is finding the two explicit functions. So remember, one would be the positive, one would be the negative. Those are my two functions. So part B asks me to graph that. So you are either going on your calculator and graphing it, or I'm going to go back up here, and if I divide by everything by 144, that would be x squared plus y squared. This would be over 16. This would be over 9 is equal to 1, right? I believe so. So it's an ellipse. 1, 2, 3, 4. 1, 2, 3, 4. This is why we did this. So I'm going to have one part that your calculator, if you graph, I don't know why it does that. Why does it do that? If I graph a positive 9, negative 9x squared plus 144 over 4, it's going to give me this top half of the ellipse. When I grade the graph the negative, so this, maybe I can do an, no, I can't do an arrow. Why won't let me do an arrow? This is a negative square root of negative 9x squared plus 144 over 4. So this is the top half, this is the bottom half. The directions ask you to label the parts given by the corresponding explicit function. So you have to tell me which one belongs to the positive half, which one belongs to the negative half. Okay, so that's part B. That's the graph of my ellipse. Again, you could have done that in your calculator. Then it says differentiate the explicit function. So it wants me to go back here and wants me to differentiate these. Now, I know there's two functions. I'm going to lump them together, and I'm sorry if that bothers anyone, but here we go. So before I do that, I'm going to rewrite this. So y is equal to, and I'm just going to rewrite it. I'm going to bring that plus or minus out front. I'm going to bring that 1/4 out front. Instead of writing the square root, I'm going to write negative 9x squared plus 144 to the 1/2 power, because I really do not want to do the quotient rule, and I shouldn't do the quotient rule because this is a constant, and I really don't want to do that. So now when I do that, there's my lovely family again. I am going to use the chain rule, so I'm going to first, I'm going to plus or minus, here's that 1/4, then I'm going to bring the 1/2 down, so 1/2, this whole thing is going to be raised to 1 less power, so 1/2 minus 1 will be negative 1/2, and then I'm going to take the derivative of what's inside here, which is negative 18x. So now when I multiply, do we agree that 2 and 18 will be 9? Yes. So I'm going to have this negative sign. When I multiply it by this plus or minus, it's just going to flip those signs. So I'm going to write minus plus. Still the same thing, really doesn't matter. The 9x will go in the numerator. The 4 will go, still stay in the denominator. And then this, since it's to the rate negative 1/2 power, this negative 9x squared plus 144, the square root will go in the denominator. So that's the derivative when I do it explicitly. So I found the derivative explicitly. In order to do that, I had to solve this equation for y and then take the derivative of what I did. Part D asked me to find dy dx. I'm sorry, yeah. Wants me to find dy dx. So I'm going to go back here and I'm going to find dy dx implicitly. So let's have a nice happy color for that. So many choices. So when I do D, oh, that's a lovely color. I'm going to do 18x, because that's the derivative of 9x squared, plus the derivative of 16y squared will be 32y. And then I'm going to write dy dx. And the derivative of 144 is 0. So when I'm solving for dy dx, I'm going to take this negative, I'm going to take that 18 over to the other side. So I'm going to have 32 dy dx is equal to, well, there's a y there too, is equal to negative 18x. And solving for dy dx, I'm going to have negative 18x over, that's an x, over 32y, which will be, I forgot to put in lowest terms, negative 9x over 16y. And so it says find dy and show that the result is equivalent to c. So right now you're looking at c, and you're looking at this, which this is my derivative. This is my derivative for c, and I'm looking at my derivative for d, and I'm saying, well, the only thing that looks alike is that 9x in the numerator, but this 16y and this look nothing alike whatsoever. But that's because you're going to have to now, fun fact, is you have this y here, and I'm afraid to write this y, oh, bad color choice, is equal to this y over here. So now I'm going to have to substitute this in for y to show that they are the same. So let's pick a different color. So much fun. So when I go down here, I'm going to dy dx. Here's this negative 9x. Here's this 16. And in place of y, I'm going to write what y was equal to, which is plus or minus the square root of negative 9x squared plus 144. And this is all over 4. So the 16 and the 4 will simplify. So this negative 9x will stay the same. This 16 and 4 will simplify to 4 times the square root of negative 9x squared plus 144. This plus or minus is just going to change this to plus or minus up here. So the signs are going to be either or. And now you can see that that matches what we had in part C. So they do match. And that's the extra thing you're going to have to do to verify that they're the same. You're going to have to go back and substitute in for y, whatever you had y is equal to. A lot of algebra in that. Okay, moving on, find the dy dx implicitly. So again, I'm going to have to use the product rule. So when I use the product rule, I'm going to first leave this 2 sine x alone. Take the derivative of cosine y, which will be negative sine y dy dx. And then I'm going to leave that 2 out in front. And then this will be plus, take the derivative of sine of x, which is cosine of x, times cosine of y. And then is equal to the derivative of 1 is 0. So I have this 2 out in front, so I'm going to divide both sides by 2, and it's still going to be 0. And y I'm at, this is going to stay on one side, so negative sine x sine y, that's what has the dy dx, will stay on this side. This will go to the other side, so I'm going to subtract it. So negative cosine x cosine y. Solving for dy dx, I divide both sides by negative sine x sine y, negative sine x sine y, and dy dx in simplified form, the negative and negative will be positive. This will be cotangent of x, and this will be cotangent of y. And that is my derivative of that function. Moving on, here I have, this is the first one where I'm going to have to find the slope of the tangent line. So I'm going to actually have to find the slope at a point. So I'm not going to solve for y. I know I can solve for y. I'm not going to do it. That's not the point of the lesson today. So I'm going to use the product rule. So I'm going to leave x alone, take the derivative of y, which would just be 1 dy dx. And again, I know you don't have to write the 1. I'm just doing that to show you what I'm doing. Plus the derivative of x is 1. And then I'm leaving y alone, and then the derivative of 4 is 0. So when I do this, I'm going to have x dy dx is equal to a negative y. I just brought that y over to the other side. Now to find dy dx, divide both sides by x, and I'm going to have negative y over x. So that's my derivative. To find the derivative at this point, this is my x and this is my y. So I'm going to have to substitute those both in. So I'm not just substituting in x anymore. I'm going to have to substitute in x and y. So this will be derivative of y in terms of x, negative, and then y is a negative 1 over x, which is negative 4. So I'm going to get a negative 1/4. And that's my derivative at the point. It doesn't want the it just wants the slope of the tangent line. So that is the slope of the tangent line. Don't have to find the tangent line, so I'm not going to do that. Next one, find the equation of a tangent line at the given point. So here is my function. Again, it's a circle. That's great. Here's the point that they want me to find it at. So now I'm going to do dy dx. So this, I'm going to use the chain rule. So this will be 2 times the quantity of x plus 1. The derivative inside there would just be 1. Again, I don't have to write it. Dx, don't need to write that either, plus. And then this will be 2 times the quantity of y minus 1. Derivative inside here would be 1. Dy dx. And then the derivative of 20 is 0. So I'm going to have 2 times the quantity of y minus 1 dy dx is equal to, and then this is going to go over to the other side, so this will be a negative 2 times the quantity of x plus 1. To find the derivative, I'm going to solve for dy dx. So I'm going to divide both sides by 2 times the quantity of y minus 1. So this will be dy dx is equal to, the 2's will simplify. So I'm going to have a negative times the quantity of x plus 1 over y minus 1. I want to find the derivative at this point 3, 4. So 3 is my x, 4 is my y. So I'm going to substitute those in. So when I do that, dy dx, so it's going to be negative 3 plus 1 over minus 1. So when I do that, see, way up here, oh, this is a 2. This is a 2, which means this is a 2, which means this is a 2, which means this is a 2. And if one day I'll learn how to edit so I don't have to do this. And this is a 2. So I'm going to have negative 4 over 2. So my slope is a negative 2. So that's my slope. So I know my slope is a negative 2. And I know my ordered pair is 3, 4. So being a slope-intercept person, I'm going to do y minus 4 is equal to negative 2. That's a 2. Times x minus 3. So when I do that, I'm going to have y is equal to negative 2x plus 6 plus 10. And that would be the equation of the tangent line. Okay, now I want to find the second derivative. And the second derivative, all I have to do is find the first derivative and then take the derivative of the derivative to find the second derivative. So the derivative of x squared is 2x. The derivative of y squared will be minus 2y dy dx. The derivative of 16 is 0. So I'm going to have negative 2y dy dx is equal to a negative 2x, because I brought this over to the other side. Divide both sides by negative 2, negative 2y actually. And when I do that, my first derivative is going to be x over y. Now to find the second derivative, so to find d squared y over dx squared, I'm going to take the derivative of this, so I'm going to have to use the product or the quotient rule. So I leave my denominator alone, take the derivative of x, which is 1, minus, now I leave the x alone, take the derivative of y, which will just be 1 dy dx, and I'm going to put that all over my y squared, so this will be y squared. So what I have, before I do anything else, I'm going to just rewrite this as y minus x dy dx all over y squared. So that's my second derivative. But what you notice is my second derivative is really written in terms of my first derivative, this here, this dy dx. So this dy dx, I can't leave that in my equation for my second derivative, but I know what dy dx is equal to. It's equal to this x over y. So I am going to substitute that in for the dy dx. So, oh, I hate it when it does that. So here's y minus x, and then in place of this dy dx, I'm going to write x over y all over y squared. And now I'm going to go really, really slow, and I'm sorry if I'm boring some of you, but this is algebra, and I don't know what to say. So this is y minus x squared over y all over y squared. Well, there's two ways that I can get rid of this fraction, because I can't have a fraction within a fraction. Is I can multiply this y by y squared over y squared, and then I can multiply by the reciprocal. I could do that, or I could say, hey, I want to get rid of that y in the numerator. So the quickest way to get rid of that y in the numerator is to multiply the top by y. If I multiply the top by y, I'm going to have to multiply the denominator by y, because that way I'm multiplying by 1. When I do this, the y times the y is going to be y squared. That's the squared. And then these two will simplify, so I'm going to have y squared minus x squared. And then y squared times y will be y to the third. So that's my second derivative, but this should look familiar. This y squared minus x squared sort of reminds me a lot of what I started off with. It was x squared minus y squared. So if you want to think of this, you can think of this as I put a negative sign out in front. Do we all agree that I can make this x squared minus y squared? I just changed the signs and it's the same because I put that negative sign there. And now this x squared minus y squared is actually equal to 16. So now I'm going to substitute that 16 back in there. Are you having fun yet? So this will be a negative 16. Oh, I hate it when it does that. But you got to keep on doing it. Interesting. So this will be negative 16 over y cubed, and that is my second derivative. And yes, yes, you do have to have that 16 there. I will not, this will be points off if you leave it like that. So that would be my second derivative. A second derivative is always going to require you, always is going to require you to substitute back in for what the first derivative is. You're always going to have that step. Okay, moving on to the next one. Okay, find the tangent line. So you find the tangent line at this point, and then you can't read this very well, so let me see. I don't know if I can do this. Have faith in me. So yeah, so here's that point. Here's the derivative. Find the tangent line of the graph. There should be a parenthesis here. So there should be a closed parenthesis there. So when I go to do this, I chose to multiply everything by x squared here. So I rewrote my function as x to the fourth plus x squared y squared. And then that's equal to y squared. Because either way, I'm going to have to do the product rule. I decided it would just be easy to do the product rule this way. So when I take the derivative, this will be 4x to the third. Have to use the product rule here. So this is x squared. And then this is 2y dy dx plus 2x y squared. And then again, just to be clear that we're all on the same page here, this is taking the derivative of that. And then this is equal to 2y dx. So I have two things with dy dx. This has a dy dx. This term here has a dy dx, and this term here has a dy dx. So since I have two other terms here, this one doesn't have dy dx and this one doesn't have, I'm going to decide to take the dy dx over there. So here I'm left with 4x to the third plus 2xy squared. That's everything that doesn't have a dy dx. On the other side, I have this 2y, and I'm going to subtract this 2x squared y, and they're both times dy dx. So I've taken it over to the other side. To find dy dx, I am going to divide both sides by 2y minus 2x squared y. So 2y minus 2x squared y. So when I do this, I'm going to have dy dx is equal to, here I factored out a 2x and made that 2x squared plus y squared. And then here I can factor out a 2y, so 2y, and then that was 1 minus x squared. And I just thought it was a little bit neater to do it that way here. That way I can see that the 2's will simplify, and I don't have to worry about those. Now, it wants me to find a tangent line, which means I have to find the slopes, which means this is my x, and this is my y, so I'm going to substitute those in. So when I substitute those in, I'm going to have the square root of 2 over 2, because that's x, and then 2 times the square root of 2 over 2 squared, plus the square root of 2 over 2 squared. Both x and y are equal to the same thing, over the square root of 2 over 2 and then 1 minus the square root of 2 over 2 squared. So when I do that, I am going to have these will simplify. They're both factors, those will simplify. The square root of 2 over 2 squared is just going to be 1/2. So this is 1/2. So 2 times 1/2 will make that 1. Plus this will be 1/2 over 1 minus 1/2. So this will be 3/2 over 1/2, and I will get a slope of 3. So then to find the tangent line, my slope is 3. And then my point was that square root of 2, square root of 2, square root of 2 over 2, square root of 2 over 2. So point slope person. So here's my tangent line. I'm going to take y minus the square root of 2 over 2 is equal to my slope, which is 3. And then I'm going to do x minus the square root of 2 over 2. So this will be y is equal to, and then this will be 3x minus 3 square root of 2 over 2. And then this one that I bring over will be plus the square root of 2 over 2. So when I combine my like terms, I'm going to end up with 2 square roots of 2 over 2. So just the square root of 2. So I'm going to end up with 3x minus the square root of 2. And that is my tangent line. And that's how I find the derivative implicitly. If you have any questions, email me, and best of luck.